Hello, everyone. My name is James Arnold, and I'm a solutions engineer for Keysight Technologies. Today, I want to show you how to run a clearing time test in our SL1221A P-Hill-based anti-islanding compliance test software. Clearing time tests make up the vast majority of the time spent to certify a device against IEEE 1547.1-2020 or UL 1741 SB. Everything in our UI is already set up, so in just a moment here, I will press the green play button and we will begin the test. First, we'll get our equipment screening results panel coming up here, ensuring that our test setup is capable of performing every test in the suite. We get a pass, so we can go ahead and close that. And now we've just applied both sides of power, so both AC and DC are applied to our EUT. Next, we're prompted to configure our EUT. I've already got mine configured, so I just click through those. And actually, some of those will be performed automatically if my DUT supported Sunspec Modbus. If your EUT does support Sunspec Modbus, you're able to automatically program quite a few of the settings for these clearing times and automate your test and speed things up even further. We can see I fast forwarded through the ramp up, but now we are at steady state 15 kilowatts. We are calculating RLC values for the first case, which is 100% tuning. We get our values there. Then an island is initiated. So now we're in the island state. We can see things destabilized pretty darn quickly here. So now we're back to a dead setup because the EUT tripped, which is good. And then in this right panel here, we're going to see some results shortly. Right, so we can see that this first clearing time was around 1.95 seconds, so right close to the 2-second limit, but still under it. So the EUT detected the island within the 2 seconds, tripped, and de-energized the island. Now we're fast forwarding a bit more, and we're running more of the clearing time test across the reactive load adjustment increments. So these start from 95% to 105%. It's a little complicated to explain exactly what that means, but basically you can take a look. Our capacitance is changing across these iterations. So we're going away from resonant RLC tuning for this EUT to slightly non-resonant tunings, which should make it easier for the EUT to detect an island state, and the clearing time should be decreasing the worse the tuning is. And we can kind of see that with our trend lines here on the graph. So both of them are now negative slopes, so our trends are decreasing on both sides, which is a criteria for passing the clearing time test. And as we just saw, the software determined that this was a pass. Now, during the test and after the test, we can also use this panel to take a look at waveforms, so RMS waveforms like this one, or we can also take a look at some instantaneous curves if we so desire. And so we can use these to quickly verify the results that we just got, or we could dive into our data results file and take a look at the CSVs directly for the data. That's all for today. Thank you everyone for watching.